Hello friends, let's continue with our series. For the lecture number 11, we will be learning about queue data structure. Let's begin. So what are the queues? A queue is a linear data structure that follows first in, first out, FIFO principle, right? So as we discussed previously, a stack is a LIFO principle, which is the last in, first out principle, and the queue on the other hand is the first in, first out principle. Let me make some of the disks here to give you a better idea. But first, let's understand about the queues and then we will understand how it exactly works. The element added first is the one removed first, right? So if you add an element, in this collection, if this is the first element, provided these elements do not exist yet, this element, which is the first to insert, will also be the first one to be removed, right? Elements are added at the rear and removed from the front. So you add elements on the rear part and you remove them from the front part, right? Common operations include NQ, which is insert, and DQ, which is remove, right? It is used in CPU scheduling, printer queues, BFS traversal, and buffering data streams. Basically, if you have studied about the operating systems, you might already be familiar with the CPU scheduling. In this, basically, we assign different processing power or resources of your CPU to different tasks that are assigned to the computer. This way, the CPU handles the request of the tasks that are added in the queue. In the printer queue, well, the printer works in a following way that whichever command or whichever instruction is given to it for printing, it prints that one first and it goes on to something that is given to it later. So if you give a 5 task job to a printer and then you give a 1 task job to a printer, the printer will not do the 1 task job because it has first been given the instruction of the 5 task job. So the 5 task job is already in the work of processing. However, the other tasks have to wait. They have to stand in the queue. A queue is also a line, right? A queue outside the computer vault is a line, right? The line that we stand in, like we make a queue at a counter or we make a queue at a movie theater and so on. So in this way, in the printer queues, the instructions are waiting one behind other and behind other and so on. This is done to save time and increase the system efficiency and also to do the jobs in a specific order because it works in a first in first out principle, which is also very close to something like first come first serve basis, right? Then we have the BFS traversal, which is the breadth first traversal. You might already be familiar with this thing. Then we have the buffering of data streams. So whenever you are watching like a YouTube video or like watching a streaming video on like a gaming platform such as Twitch, etc., the data streams are sent in form of small data packets, and a lot of these packets are sent to the server, and once they are sent to the server, they wait there in a queue, and when they wait here, they are already sent and waiting for another or the later packets to be arriving. So if there is a network congestion, if there is a problem in the signal or the network and you are not able to access YouTube or Twitch using the internet, These packets have been added as a buffer stream. This is why you see the video even for couple of more seconds than compared to the video that you will be seeing if it were published live. Even on the live videos, there is a little bit of data streams in the form of buffers. So that's why you have noticed that when you're watching a video on YouTube and you close the internet or the internet connection is gone, the video still plays a little bit, right? That's because of the data packets, the buffering data packets with the data streams, right? And it can be implemented using arrays or linked lists. So that was about queue. Now let's just see a little bit of how the queues works. So presuming this is the rear of the queue, you are going to be adding data here. Okay, then when you want to add one more data, this data will be shifted to this place. Okay, the data will go down and the place will be there to put another data. Then when you want to put one more element, this will go down and this will go down and you will put one more data, and similarly so on until you reach here. Now when you try to put any data, if you try to put any data here, this will be removed once you pull the data, because this will push this, this will push this, this will push this, this will push this, and this will push this, and this will be removed. Removed from where? Removed from the front, because it is a first in first out. That's all about queue. I hope you were able to understand, and thank you for watching.